All right, so let's take a look at the next three problems on here, kind of finish up that kind of 2.4, 2.5 chunk of the review. So my first question here that says find all, and notice that the word all is underlined. It's kind of giving you a hint that we're not only looking for real zeros, we're actually looking for the complex zeros. Like in other words, if it's a third degree, then we need to find all three. Similarly, in number 7, it actually says find let's get the whole thing down. So when I looked at number 1, notice that I have a couple of them in here already, but I've got this polynomial ready to go. I'm going to look through my rational roots theorem and hope that I found one. And I actually still have the same questions that I asked from the previous problem. And I got lucky here, and I literally did. I can see -1.5, which -3/2 is one of my rational roots as a possibility. So keeping in mind if I have a third degree and I found one of them already, then there's only 2 left, and that means I'm not going to have to work very hard because the quadratic formula is going to get me the rest of the way home. So in my multiplication, and I know some of you aren't going to like this as well, but you drop your 2. And I don't think 3/2 of 2 is a problem, but then 3/2 of 12, people are going to be bothered. But remember, 2 goes into 12 6 times, which is going to be 18. And of course, a negative times a negative is a positive. Similarly, 2 goes into 20 10 times, and that 10 times 3 is -30. Now, keep in mind, again, we have this 2x plus 3, which was my factor. Now, the problem didn't actually ask me to find the factors. It asked me to find the roots, and I already have one. And that leaves me with a 1, -6, and 10, because just like the last problem, we needed to actually reduce that problem by dividing by 2. So we're down to this little quadratic right here. And either through the quadratic formula or by completing the square, if I'm going to find this, I think I'm going to go with completing the square, because if I go ahead and I cut that -6 in half and get -3 and square it, I get 9, which is going to leave me with x minus 3 quantity squared is equal to -1. Now that's actually kind of nice, because when I take the square root of both sides, that's going to give me, I'm going to go ahead and come right up here, that x minus 3 is the square root of -1, which of course is I, and so that was plus or minus because we took the square root of both sides. So that means if I'm going to find all of the zeros, then those 3 zeros were -3/2, and when I add that 3 to both sides, that's 3 plus and minus I, for a total of 3 roots for my cubic polynomial. Now, number 7, I kind of gave you a little bit of an out here, because it actually tells me right off the bat that 1 plus 2i is a root. So out of the 4 roots, I've actually already given you 2 of them, because as soon as you know 1 plus 2i, then 1 minus 2i is also a root by the conjugate roots theorem. So depending on how you like to do that problem, some of you guys have really shown that you actually really prefer the long division to the synthetic. So this time I will go ahead and do that problem using the long division. And let's remember our little trick. So if 1 plus and 1 minus 2i are my 2 roots, then if I put those together, I add them together, and that gives me 2, so I write -2x. Just a little hint, a little reminder of our special trick that we did. And then we squared both roots, which is a 1 and a 4, which makes 5. So our process says, let's go ahead and get an x squared. That's -2x cubed and plus 5x squared. So we did our multiply. Now we need to change our signs. There's a minus there. That's going to make it a plus there and a minus there. We've got a -6x cubed. We've got a positive 22x squared and a -50x. Not exactly the most pleasant, but we're doing all right. And we need a -6x next, which is a -6x cubed, a positive 12x squared, a -30x. I'm getting suspicious that I did something kind of nice. We're going to change our signs one more time. Let's see, bringing it on down. It looks like I've got 10x squared minus 20x plus 50. So that's going to leave me with a 10. And lo and behold, we have exactly the same quadratic that we had on this previous question. So it looks like our roots, all four of them, were, I'm going to write it down here, 1 plus and minus 2i. Those were the given values, and then we know this one because we found the same answers over here. We got the same exact one, so that's 3 plus or minus I. That was kind of convenient. Now, our last one is we're going to go ahead and write this polynomial, real coefficients, minimal degree, with certain multiplicities. Now, the whole point here of minimal degree is it says 1 plus 5i, that's 1 minus 5i. And then this one has a root of multiplicity 2, so I got 1, 2, 3, 4. So I don't need anything extra. We're not going to write anything fancy because I think it says just find a polynomial. It doesn't say the polynomial, so I can be general. And so my function is going to be x squared. Now keep in mind, if I add those, I get 2, so I write minus 2x. I square the 1 and the 5, and that gives me 1 and 25 is 26. And then, of course, 3x plus 2 is the factor that jives with that root, and it is going to be squared. Now, as it turns out, we can do some work and distribute that. I do know that a lot of people struggle when they multiply 3x plus 2 by itself. That 3x plus 2 times an extra 3x plus 2 has a 12x and a 4. If you need to write that twice so you can literally see all the little pieces as you multiply, please feel free to do so. And if you keep going just a smidgen further, you're going to get a 9x to the 4th coming from those two pieces. You're going to get a minus 6x to the 3rd coming from that piece and that piece. You're going to get a 210x squared. There's actually 3 of those, 4 there, negative 24 there, and a whole bunch of them there. We have 304 x's coming from that piece and that piece. And last but not least, there's 104. And if we wanted to be really thorough, the only thing left to do is we could put an a in front because sometimes there could be some leading coefficient that could actually make that a little bit stronger, which could find not only one polynomial, it's going to find literally every polynomial that has those roots. So that's going to end it for problems 6 through 8. Hopefully that's helpful. I'll see you later. Hopefully you're having a good vacation.